All right. Hopefully this will be a better shot at going over 3.2 for us. Some people had told me, hey, your sound quality cut out a couple of times. Thank you for telling me that. I know. So we're going to re-record this and see what we can end up with. Try to do this maybe similar, but not exact. Okay, cannot minimize. Great. Share my screen so we can have a look at how to find a standard deviation. Okay, so here we go. There we go. Beautiful. Okay, so we have measures of spread. Okay, that's what we're talking about today. Measures of spread. Right, so here we go. Okay, we have range. Feel like range. We have standard deviation. Okay, and then variance. Okay, now range is just the biggest number minus the smallest number. Okay, so that's pretty straightforward. That's an easy one to deal with. Standard deviation, well, we have two formulas here. Same with variance, we have two formulas. Okay, now standard deviation, we can have here, this guy here is called a sigma. Okay, it's a Greek letter for, yes, it's a small one, but this stands for the population standard deviation. Okay, so the formula for that is we're going to take each observation. Okay, little xi, this means if I is 1, that means the first one. If I is 2, that means the second one. I is 3, that's the third one, and so forth. Okay, from each observation, we're going to subtract its mean. Okay, now mu, that symbol for me is mu. Okay, if you are in biology and you deal with micrometers, micrograms, that is the U symbol that they use for that. Okay, mine is kind of a combination of an M and a U, like the way it sounds. But if you want to tell me my Greek penmanship is terrible, that's true. Okay. We're going to square each of those numbers. Okay. We are going to add them up. This is a capital sigma. Okay, and again, it's a capital Greek letter, sigma, and all it means is add up everything that comes behind it. So we're just going to add all this stuff up. Okay, we are then going to divide by n. Okay, capital N. This is the population size. Okay, so if we are dealing with all the aqueducts that are left in the world, that might be all the aqueducts that have been built by the Roman Empire, we might have 300. Okay, I don't know. If we want to talk about all the trucks that are going, that are in service in the United States right now, that's going to be several thousand. Okay, and at the end, we're going to go ahead and we are going to take a square root. Okay, we'll do an example of this in a moment. We also have S. Okay, this is the sample standard deviation. Okay, now I'm a little bit better than I used to be as far as telling you, is it a population or a sample? Samples are some of the objects in question. We like statistics because we like to do samples. Okay, if I wanted to say, well, I'd like to get the the gas mileage of all the cars in New Mexico. There's cars that haven't run that are still cars, right, for the last 30 years, and those would have to be included. Okay? So that's sample. That's population. It's all of them. Sample. I might decide that we're gonna go to like 2 or 3 emissions places, and we're gonna get all the gas mileages of all the cars that go to those emissions places during the first week of October. Okay, it's not a very good sample, but it's a sample. Okay, so we like to work with samples because it's easier to define, it's easier to gather them. Okay, sometimes it's a little hard too, still, but it's better than getting the population, right? When they want to do like polling for who you're going to vote for, like they don't ask everybody. That's what election day is for. They want to know before that. So they sample, they ask some of the people that are likely to vote, who are likely to vote for. So that's what we're doing there. Okay, formula for this. Same idea, we're going to take each observation, so the first one, the second one, the third one, etc. From that, we're going to subtract off the average, okay? This guy is pronounced X bar, and here's the sample average. Okay, mu, that's the population average. Okay, and then again, we're going to square each of these numbers. We're going to sum them up. Okay, so add them up. Okay, still capital sigma. We're going to divide by n minus 1. Okay, if it turns out that if we divide it by n, that we actually make this a little bit too small because we're dividing by a bigger number, right? We divide something by 10 versus dividing it by 9. Dividing it by 9 is going to be a slightly larger thing. Right? So, for example, right, if we have 90, if I divide 90 by 10, I get 9 pieces. If I divide 90 by 9, n minus 1, we would have a value of 10. Okay, so if I divide by something a little bit smaller, it makes the number that we end up with a little bigger. It's just how to it has to deal with like not having a biased value here. And then again, we're going to go ahead and take the square root of both numbers, or this whole thing. Okay. All right. Again, we're going to do an example in just a minute. Okay, I just want to go over variance for just a second. Variance for population variance, that is sigma squared. We just don't take the square root. Sample variance, S squared. Again, we just don't take the square root. When we do the homework, they're going to ask you for these numbers. That's great. In quizzes, I'm generally not going to ask you for variance. Okay, and you're going to use your calculators for this anyway. All right, so I don't want you thinking I'm going to have to memorize this formula. No, you're not. Okay, that comes out of your calculator. This is a calculator value. Okay, this is not something that I'm expecting you guys to do, especially later on in the class when we have 12, 15, 30 things you have to find the standard deviation of. No, it's a calculator thing. We're not doing this. Okay, but let's do it once so you know what the calculator is doing, and we can go on from there, okay? So, there we go. So let's have a look at your homework. In this case, it says find the sample variance and the sample standard deviation for the following sample. Round the answers to at least two decimal places as needed. Okay, so what do we have here? Okay, problem number 1, 3.2. Okay, so we're going to just make a column: 17, 40, 22. Okay. 17, 40, 22. What else do we have? 15 and 12. 15 and 12. Now remember, this was a sample, so we're going to be using the sample standard deviation formula. Okay. Now the first thing we have to do is we have to get the average here. Right? So I've got a little calculator emulator. Okay. You're allowed to use one, but you can't use one on the exam because, or on the quizzes, because it shuts off the internet. And you're going to need an actual calculator. Okay. The CNN library loans them out. So if you have access to that, you can certainly use those. If you want to borrow one from somebody, I don't have a problem with that. Okay, if this is your only math class, I would recommend trying to either borrow or rent a calculator rather than spend over $100 on a calculator that you're going to use for one class. Okay. So add them up: 17, 40, 22, 15, and 12. We're going to divide by 1, 2, 3, 4, 5. That's how we find an average. Okay, we get 21.2. Okay, that's my X bar, right? That's our average. Now, next column, what I'm going to do is I'm going to take 17 minus 21.2. 40 minus 21.2. 22 minus 21.2. 15 minus 21.2. 12 minus 21.2. 21.2 is our average. The first one subtracts it, the second one subtracts it, the third one subtracts it, the fourth one subtracts it, and the fifth one subtracts it. That's exactly what we are here. This was x minus x bar. Okay. And then we're just going to equals. Okay. Some of these are going to be negative numbers, some of them aren't. That's okay. So we have 17 minus 21.2, negative 4.2. We have 40 minus 21.2. Oops, that's not what I want. 40 minus 21.2. That's better. 18.8. Okay. We have 22 minus 21.2. It should be 0.8, right? 0.2, sorry. Oh, of course it should be 12. Oh, let's confirm it. There we go. That's better. 0.8. Okay. And then we're going to have 15 minus 21.2. Negative 6.2. And then finally we have 12. It's 21.2. Okay, I'm going to. Now, when we square these numbers, okay, you know that when we square a number, we are going to get the positive value. So let me go ahead and square the previous answer. That's 9.2, negative 9.2. Sometimes it'll give you a negative number here. Okay? So if you type in a negative number and then square it, and it tells you a negative number, you know that that's not correct. It's really a positive. Okay? So this is 80, what was this? This is 84.64. And we're just going to go through and do the whole thing. Okay, 6.2 squared, 38.44. 0.8, so maybe 0.64, good. Okay, 18.8, 18.8 squared. Okay, it's 353.44, 353.44, and then 4.2 squared. So why aren't you typing in the negative? Because it's going to be a positive number after I square it. We don't need to type in the negative. Okay, so here we are. We are at x minus x bar squared. Okay. Now we have to add these up, right? That was the next thing, was to say the sum of x minus x bar squared. All we're going to do is we're going to add up these numbers. Okay, so let's see if my 10 key is still good. So let's see here. We have 17.64 plus 353.44 plus 0.64. Oops. Oh, I see what's going on. I think here. Okay. 17.64 plus 353.44. Sorry about that. 64 plus 38.44 plus and 84.64 plus. Oops, quit. Dang it. Really? 17.64 plus 353.44 plus 0.64 plus 38.44 plus 84.64. There we go. 494.8 eventually. Okay. This is the problem. This is the issue. If you know an old person, somebody who went to college in the 80s, and they say, "Oh, statistics was so hard," it's because we didn't have calculators to do this. We had to do this over and over again. I think I'd be better at it, but that's what we had to do. Did not have Excel, wow. Some of us had Excel, next to some of us had Lotus 1, 2, 3, but that's where we were. Okay, so not everybody had that. My portable computer weighed about 30 pounds. Okay, 1, 2, 3, 4, 5. So we have to divide by 5 minus 1, right? N minus 1. We have 1, 2, 3, 4, 5 observations. So there's my 5 minus 1. That is better known as 4 equals. Okay, so we're just going to go ahead and do that. We're saying divided by, that tells you what the previous answer was. Okay, divided by 4 equals 23.7, 123.7. And now what we're going to do is we're going to take the square root here. Okay, so second function square root. Second function, this one gives you the ANS button. So that's the previous answer. So this will be the square root of 123.7. It should be that 11-ish. All right, 11 point, what did they say? How many decimals? They say 11.12. Okay. Now, if we square this, right, that goes back to here. So my sample standard deviation, right, 11.12. My S squared, that's just without the square, right? So if we square this back, we should get 123.7. And that should be my standard deviation and my variance samples. Okay. So sample variance is 123.7. Sample standard deviation, what do we have here? 11.12. Right, fingers crossed. All right, hooray. Now, we are going to use the calculator. Okay, I know we used the calculator before, but we're going to use like more of the calculator here. So what I'm going to do is clear. Okay, I'm going to make sure my lists are cleared. You probably don't have to do this, but if you are renting your calculator from the library, you will probably have to do this. If you did your homework previously, you're going to have to do this. Okay, so to figure out the standard deviation, okay, you're going to go to stat, right, the stat button here. Okay. We're going to edit because we're going to edit our list. Okay, so on list 1, we're going to just punch in. We're going to say this is 1740. Oops, 40. I'm just hitting the enter button, okay, or the enter button here to get to the next one. You could also hit 22 and then hit the down button. Okay, so putting this in is not that terrible. Okay, and 12. All right, here we go. All right, something here. Pause for a moment. All right, please forgive me. So let's see here. We have 40, 17, 40, 22, 15, 12. Doesn't matter which order you put these in. Okay. Next thing we're going to do is we're going to go back to stat. We're going to go over to where it says calc, and we're going to choose one variable statistics. Okay. So that was stat. Over here, calc. You don't even have to choose anything, just hit enter. Now it's asking us, what would you like to do this on? Okay, so stat, calc. What list would you like to do this on? I'm going to say second function, L1. So it knows it's going to do first variable statistic, one variable statistics on list 1. Okay, and then we'll pop that in there. And what are we interested in? Yeah, we can double check. What's our mean? Right, we got 21.2. Hey, we got 21.2 for our average. Of course we did. Our standard deviation, we got 11.12. Hey, look at that. Now, this doesn't tell you the variance. So you're going to have to take this 11.12 button, right? We're going to take 11.12 and square it so we can get back to what we started with. Okay. And to 2 decimal places, well, 1 decimal place, we got 123.7. Okay. So I don't know if that would have been the right answer, but there we go. Okay. So stat, calc, one variable statistics. Which list did you want to do this on? Enter, and then you could read off the parts that you need. Okay. Now, in other stats classes, you might need some of these other things. Right? Here's my population standard deviation. Do not, like if I ask you, like, tell me the mean and the standard deviation. Do not just type out everything you see in your calculator. I will mark you wrong for that. Okay. I want only the things that I asked for. I don't want you just to, well, here's what my calculator vomited out. Go ahead and write that down. Don't do that. But that's how you find a standard deviation, okay, in your calculator. Let's do one more in the calculator. We're not going to do the whole thing here. We're not going to do the whole, write it down, everything. Okay. Let's see here. Variance. I think you could probably, let me check to see what else we got. Okay. So this one, so let's go one more. There we go. This is the number of active breweries in samples of states, east and west. So it's a sample of states. So let's see what they wanted. Compute the sample standard deviation for the number of breweries east of the Mississippi. What do you want of that? That part B asks us to be for west of the Mississippi. So what I'm going to do, okay, is I'm going to go back to stat. We're going to clear the last list because I don't really care about those numbers that we just put in. Enter. Clear list 1. Okay. Now, what we're going to do is we are going to go ahead and put these numbers into a list. They're different numbers. Like that's okay. We're not doing anything more than that. Okay. So we're just going to say stat edit. Okay. We're just going to type in these values. So I need a 20. Okay. 76. I need 46. 14. 19. 20. 18. 10. 47. And 22. Now I'm using this arrow to go over. I'm just going to do this to L2. So California has 305, 17, 31, 11. I'm actually, no, this is a different sample. 21, 6, 41. There's 6 breweries in Louisiana. So I never believe. Okay. So we're going to go to stat. We're going to go to calc. We're going to do one variable statistics. Don't type in both lists. We're just going to do one at a time. If I type in both in, that means something a little bit different. Okay, so my standard deviation, right? Sample, right? They said samples. Okay, so we were finding the sample standard deviation. So that was 20. How many decimal places did they want? 1 place. So we wanted 20.6. That 5 is going to boost that 6 up to a 7, so 20.7. Check up to there. Right, fantastic. Sample standard deviation for the breweries west of the Mississippi. Who would have guessed, right? Stat, calc. We're still going to hit one variable statistics, but now we're going to do this on list 2. Again, you don't want to do this at the same time. That'll do a different calculation. I'll show that to you a little bit, maybe in the next video. Okay. But that sample standard deviation, 106.7. Okay, 106.7. 106.7. Check answer. Right, hooray, and we're good. Okay. So I will return to do a little bit more of this. 23 minutes. Do I want to do more? The population standard, the next one is population standard deviation. We're just going to pick the one that looks like the segment at the bottom. So this would be the population. That's a big problem. Okay. Let's do part of this. Okay. So we're going to do stat. We go ahead and say clear list. I'm going to clear both of them. So list 1, comma, list 2. Okay, and we're going to do part A for this one. Just going to say find the population standard deviation for 2012. Okay. So this is going to be, we need stat, edit. And we're just going to save for list one here. Okay, I'm just going to move back to list one. And we're just going to type this in 193.5. Okay, 129. 9, 208.6, 174.3, 103.7. All right, 359.5, 448, 265.4, 131.9, 311.6. All right, so I go back to my stat, go to calc, one variable statistics, and we have list. If you only wanted to do list one, you can just type in enter. It'll assume that you meant the first one. So there you go. Now for this one, the population standard deviation, do you see this little sigma x? Okay. We'll get to two variable statistics. The reason why there's a little x here is because they're also going to be a y. Okay. So the sigma x is 106 point, how many decimal places do they want? Two decimal places. So 106.12. Okay, so this is 106.12. Okay. Notice, like, even with this, like, you can tell there's a difference. Okay, I can tell there's a difference. So if I ask you for one and you give me the other, it's not the right answer. All right, so you have to know the difference between sample versus population. If you give me both of them, it's like, oh, I'll insulate myself, give you both. I'm still going to mark it wrong. You didn't know which one you wanted to give me. It's wrong. Okay. So there we go. All right, I'm going to leave this with that because I think we've been here long enough, and I will continue in the next video. Okay, so thank you very much for coming, and we will see you in just a moment.